Well, thank you, everybody. I'm super excited to be here. I've heard of Scale for many years. I've been a developer, a user, maintainer of open source pretty much my entire tech life, so it's always been a goal of me to be here, so super excited. And thank you for the organizing committee for all the great work. I know this is like mostly volunteer-driven, and it blows my mind because the high quality and how cool it is and all the conversations. So today I'm here to talk about how we can use tools like Kubernetes, Crossplane, and Octado, not only as you were saying, as infrastructure, but for development, and how we can use them to make our lives as cloud-native developers easier. So my name is Ramiro. I am one of the founders and maintainers of the open source project Octado. If you want to connect after the conference, there's a QR code there. I'll take you to my blog where you have links for Twitter, Mastodon, and other places. I'm always around, love to talk about tech, dev experience, dev platforms, all those things. I'm going to be at KubeCon in Amsterdam in a few weeks. If anybody's going, let me know. Love to see you, see more friendly faces there. So for anybody who's been in the cloud native space for a while, whether you're old or new, you know that building cloud native applications, it can be hard, you know? Many years ago when I was starting my career, you know, LAMP stack was kind of the hot thing, and that's a long time ago. And it was relatively easy. You start the LAMP stack server, everything was there, run your machine, and then when you were done, you would like copy that to your server, wherever it was running, and that was it. Since then, things have changed a lot. VMs, microservices, containers, GitOps, DevOps, infra as code. It has made our applications a lot more robust. It has made our applications easier to scale. But now we have to know a lot more than before. Like when you're thinking of like, hey, I'm going to build an application, I'm going to work on something. Well, now we have a lot of things to worry about, right? Our source code, our IDE. Where do I build my containers? Where do I get my images from? How do I run my database? Where do I get a debugger? Running my tests, my dependencies. And then we start kind of getting deeper into the stack of like infra, application configuration, security roles, network configuration, infrastructure. It's a lot. Like sometimes, you know, it feels like you're pushing this huge ball of things uphill. And it's hard because, in my opinion, a lot of the things that happened in the last 10 years have been very focused on the production and operational concerns we all had. And we did solve a lot of problems. Kubernetes, containers, VMs, like they solve a lot of things. I don't know if anybody here remembers the days when you had to go to a physical data center and try to fix things when like a network cable was unplugged. I'm very happy to say that I haven't done that in 10 years, and I hopefully will never do it again. So those things, it did help. But during that time, developers, they kind of got left sidelines, right? There was all these tools, but developers are still kind of like stuck on like, hey, my local machine. Which means that we are always spending all this time trying to make this, you know, like global scale applications fit our laptops. We're trying to run things like Minikube, like Docker Compose, or sometimes, you know, the local version of your application with like mocks or less pieces. And we developers spend a lot of time kind of handcrafting these dev environments. And for the longest time, you had to do this by hand. Luckily, over the past few years, we've seen a lot of really cool things come out on the developer experience world. Vagrant, a few years ago, kind of like the granddaddy of this. Docker, of course, Nix, Telepresence, now Octado, hopefully, and a few others, to help kind of solve this problem, because it's a very important problem. We as developers, as engineers, we want to solve cool challenges. We don't want to spend like too much time digging into all this list of things I showed you before. We want to be able to get that done and then get on with our work and ship cool things that make our users, our customers, or our community happy and excited of what we're building. So developers need modern tools, right? We can't keep building cloud-native applications the same way we build, you know, like monoliths, where like everything runs on your machine, and then at some point, like, okay, I'm done, push it to CI, and let's see what happens. Like that world, it's not great. It's not effective. It creates all this frustration, especially as we, as an industry, you know, as we shift, as we have like developers, which is amazing, from different backgrounds. Some come from like boot camps, others come from like more like traditional schooling or changing careers. Like we can't go back to that world like you have to know everything. Just the cognitive load of having to keep configuration, security, network, code, debugging your head. It's just hard. So we need better tools. And part of like what I've been doing for the last few years is kind of talking more about like, there are all these modern tools that if we put together, we can start building this next gen, what we've been calling cloud native dev experiences, to make it easier for everybody to build cloud native apps, make it like as seamless as, you know, what the LAMP stack or like what Rails S was many years ago, but for like for these modern stacks. And that's what I want to show you today. Today I'm going to focus on two of my favorite open source projects. I'm biased because I started one of them, but Crossplane is probably my favorite project from the CNCF. It's a project that allows you to manage cloud infrastructure from Kubernetes. Once you install Crossplane, they have this beautiful model of composition where you can define some YAMLs of like what does a database, what does a blob storage, what does a queue look like. Behind the scenes, Crossplane is doing all this translation of like what that looks like for AWS, what that looks like for GCP, what that looks like for like DigitalOcean. So I like it because as a developer, this allows you, or as a platform builder, this allows you to define the cloud infrastructure as code using YAML, which is the de facto language for all things Kubernetes, put that on your repo, abstract away all these complexities, and then enable your developers to be able to provision these resources using the same language and the same mechanics of kubectl apply, kubectl delete, kubectl get that are used on a day-to-day. So it's something really exciting. I really like this they have this concept of, I was saying earlier, composition of abstractions. The idea that you can create a platform. You can start building, using their model, their CRDs, to do things like say, hey, I have this object called database. The fact that internally this is a Postgres SQL on AWS, on US West 2, with this much memory, this much storage, with this backup policy, is completely abstracted from the developer. The developer has a type, and I'll show this in a demo in a second, called RDS instance, and that's all they need to care about. And that's super nice because this allows you to start using this cloud infra, which is what you're using in production, without having to be an expert in AWS, without having to go through the console and try to figure out, how do I deploy this? Where do I get permission? Which account should I use? And that's part of what I was saying earlier of like making it easier for developers to use all these things as part of the day-to-day. GitHub.com/crossplane/crossplane. It's a really cool project. There's a Slack. They're like super helpful there. I had some issues last night, and I was like posting messages at like 1 in the morning, and people were helping me out, kind of set up my cluster. It's a beautiful community. There is a company Upbound behind, so if at some point you need like support or kind of more professional services, they also provide that, but it's a thriving open source project, part of the CNCF sandbox. I think now they graduated, but they're there. And just all around, like really cool people. If you haven't tried it out, and you're like in the Kubernetes world, and you use cloud resources, I highly recommend this. It integrates so well compared to other things like Pulumi or Terraform, who might not be as Kubernetes friendly as Crossplane is. And the other thing, it's Octeto. Octeto it's a project, it's an open source project that I started with a couple of friends from the Kubernetes community about 4 years ago. The goal of Octeto is to give developers a CLI, single binary. You download this to your laptop. You run one command, Octeto up, and then this will deploy your dev environment on Kubernetes. Very similar in the ethos like Crossplane, which is you want to create this abstraction where one person configures this for your team or for your community. You can put it in a repo. And then, hold on, there we go. And then everybody can just work. Our idea was that one command, Octeto up, and then everything just runs on Kubernetes. With Octeto, the big difference from like normal development is that instead of building your containers locally and running everything locally, everything is running on Kubernetes. And Octeto will do things like synchronize your code, give you a remote terminal into your containers, do all the port forwarding needed to connect a remote debugger to run your tests, to give you this kind of best of both worlds, we hope, which is local machine, your IDE is fast, your tools, your scripts, but then everything else is on Kubernetes. So you don't have to like fight how to run Kafka or Cassandra on your local machine. And the other thing that this gives you is this idea we've been talking about of a realistic dev environment. If your application is running on Kubernetes, we believe that your dev environment should also be in Kubernetes, because otherwise you're starting to have the typical skew between dev and prod. And I've worked for companies where you end up having a dev version of your product that runs on the laptop, and then the actual production version of your product, the one that your customers pay for. And this skew means that developers are testing for this, and they're hoping it will work here. And that's, there's that kind of like cliche that hope is not a strategy, and for development it's not. I hate having to push code and then cross my fingers, close my eyes, and hope that CI/CD will work. Hopefully it'll stay there, sorry. And that's part of what we're trying to do with this project. So it's also open source, check it out, github.com/Octeto. Octeto is a single Go binary, runs on Windows, Mac, Linux, ARM, anywhere, and all you need to have is a namespace on a Kubernetes cluster to be able to use it. But enough slides. This is Scale. It's a cool conference. We don't want to like bore everybody with just like slides. I'm going to switch to a live demo. I'm going to show you how you can use these two things to create a beautiful, I hope it's a beautiful dev experience. So first things first, I have a Kube cluster here where I installed Crossplane. It's here. Crossplane creates a namespace called Crossplane System. So if I do this, you can see everything that is running there. Crossplane has the concept of like you install Crossplane, which is like the main engine and kind of like the CRDs and all the rules. And then you install providers, which is like packages for every cloud provider. This could be AWS, Heartner, DigitalOcean, Oracle, or you can also create your own private providers, because these providers are an abstraction. They could be anything. There's this demo where they create a provider that is the Domino's Pizza API, and then they can call, like order a pizza from like a kubectl command, which is really cool. There's a YouTube video of that. Check it out. But the idea is okay, hold on. There you go. The idea is this. It's like you have, okay, one more time. I hope it stays there this time. That's the idea. Is you have this running on your cluster. And part of what Octeto gives you is that now you have this one cluster with Crossplane running there that you can share for your developers. So imagine that we are developers, and we want to work on this application. I have this to-do application, fairly simple. It's a Go service and an RDS instance on AWS as the backing store. So my admin set up the cluster. They have Crossplane running, and they give me access to the cluster. And they created, as you can see here, nicely, a namespace for myself. So in my repo, whoever set up Crossplane for me gave me this very nice YAML file that is abstracting away this RDS instance. This is one of the simplest types of Crossplanes. You can create more complex things, but for this demo, I want to keep it easy. And in this case, it defines an RDS instance. You can see this is all YAML, and it's telling me like, hey, I want to run the region, the instance size, the username. I'm not going to define a password because I want that to be like generic, like to be randomly created. The engine, which is Postgres version 12, and a few more things. Here is the admin's decision. Like the admins could create an abstraction on top of this to maybe only expose the size. And rather than calling DBT2, it could be like small, medium, large, or dev, production, whatever you want to call it. But that's the idea. I have this. So now, because I have access to a cluster, and I have this already set up for me, I can just go and do kubectl, apply, Postgres, and in this case, on my namespace. When you run this command, which I ran before because spinning up an RDS instance takes a while, this will engage the Crossplane engine. So this is kind of like the first step on this modern dev experience is you're giving developers the tools to create all this infrastructure very easy with a language they're familiar with, in this case kubectl. But you're setting up some rules. It's like which types of instances are you allowed to, in which regions, with which backup policies. Because developers don't want to ask for permission, but they also don't want to get like shouted at because it's like, why are you spinning up this super large instance that is costing us $1,000 a month that I might have or might not have done in the past. They like this, right? You have a sandbox you have everything automated, you're ready to go. So that's the first thing. You deploy your instance. So if we go here to the lovely AWS console, you can see it's there. You see I have this here called MyDB. It's here, it's MyDB. It's in the right region. It's where I created it. And this was automatically created by Crossplane for me. When I'm done, I could just as easily do kubectl delete MyDB. And I click enter, and that will delete the thing in Crossplane and eventually in AWS. So really cool thing. So in this case, what we recommend is one database shared. It's for every developer. Now, first step, I have a database. So now what I want to do, well, I'm a developer. I want to write some code. So that's where Octero kind of plays together really well with Crossplane, because now that you have a namespace on Kubernetes and you have a database, now all you need to do is run your code. So one thing that Octero does is this. It provides you with this file, Octero YAML, where you can define what you want your experience to be. In this particular case, this kind of extended example, we have a build phase where you're telling Octero, I want to build the container, call it this image, with this context, which in this case is my local folder. Octero will use your local Docker daemon. If you have a build kit pod running on Kubernetes, or you're going to use some external service, it will do it. Then you're going to tell Octero, hey, I want to deploy something. In this case, I'm using another open source project called Schema Hero. I'll get to that in a second, to create my schema, database, all that, and my application. And finally, this manifest also tells you, I want to develop. And how do I want to develop? Well, in this particular case, what I want to do for development is deploy a container called Postgres app with this specific image that we created. It has all the Golang tooling. And I just want a remote command. I just want a remote bash terminal into my container. And I want to synchronize my code from my local machine, my local folder, to /app. So the idea with this is that now you have this file that you have your dev environment or your dev experience defined as code. You have a YAML for your dev experience, a YAML for your application, a YAML for your schema, which is this one, and a YAML for the database. So everything goes in the repo, is checked in, and you have a single command, Octero up, to launch the entire thing. So before I get deep into Octero, Schema Hero is another open source project I like a lot because it allows me to do this. I can have a YAML with my database. This defines my schema. This is telling Schema Hero, hey, create a database, and then create a table with a key, with a column called item, and a primary key, item. In this case, it's fairly simple, but you can do a lot very complex things. This is useful, again, because you're reusing the knowledge that your team has. This is also using the Kubernetes language. It's using kubectl, YAML. It's everything in code. You can put it, like, you should not put your password here. I just did it because I was running out of time. I didn't want to create a secret, but you can mount a secret to do this as well. But overall, the idea is everything is there. And because it's a YAML, then you can use any other tool that understands how to manipulate YAML files, kubectl, Kustomize, TPL, any of this, to kind of continue to build this experience. And that is something that is key, is taking all these tools that we use in production to do them here as well. So we have this. We have Schema Hero. We have Octero. We have our, in this case, a fairly simple application. It's just Go app that mounts a secret and has my connection string, all those things. So now, somebody did this before. It's on a repo, and I'm ready to roll. I have my namespace, so I installed the Octero binary. It's a single binary, a Go binary that you get from our GitHub repo. It runs anywhere, and we're going to run Octero up. There's three commands that you can run. Octero build, to build your container image. Octero deploy, to execute the deploy phase, which is what we have defined there. Or Octero up, that does everything. Build, deploy, and then it will give you this remote terminal into your container. So I'm just going to save some time and do Octero up. while this runs. A couple of things that happens with Octera Up. The main thing, and one of our main kind of like new ways of developing, is this idea that when you have an application with multiple components, you should be able to target a single component and say, this is the component I'm going to be working on. This is a fairly simple application, but imagine you have an application with like 20 or 30 microservices. You run the command, it deploys all your microservices, and then you do Octera Up to the microservice you want to be working at. The beauty of this is that then you can do things like end-to-end testing, where everything else is using your production configuration, and Octera is the only one that is changing. So this run here, you can see that I'm forwarding some ports to make my life easier, and I have this remote terminal. If I do env, and let's say, hey, grep db, you see that I'm getting all the variables that Kubernetes and Crossplane injected, like the secret that Crossplane created, the variable that then I used to mount into my deployment.yaml. Everything is here automatically as I develop, which means that when I'm running my code right now to start in this case, my Go app, this will reuse the same configuration I had for my application. So the connection string, I'm using RDS. You can see here that I'm using RDS as part of my dev cycle. Any other like security model I have, my service account, my bindings, all that stuff is automatically applied. One less thing I have to worry about. And the other thing is, I'm not running Kubernetes locally. If you see here, I don't have Docker Desktop, I don't have Minikube, I don't have K3s. I'm using this remote cluster, so I have all that CPU available for me. So I'm here. I have a remote terminal, so the easiest thing to do is I'm going to go run, server, go. This is starting my application, connect to my database, and started, in this case, a web server on port 3000. Normally, you would have to create an ingress or do a port forward to be able to access the service, but one of the things that Octera does for you is automatically create that port forward for you. If you see here, I define a couple of forwards, one for my database port, one for my API port, just to make my life easier. This means that I can go to localhost 3000 and see the application running. Fairly simple application, a to-do list. First thing is, hey, hello, scale. Let's add some more. Go with the demo, or actually set up your microphone, which I've done a million times. So now I have this application. It's running on Kubernetes. I'm able to test it end to end. I'm writing code here. I know that this code, I know that I'm doing a post into this API. That works. The API is writing to a database on RDS. It works. The whole thing is packaged and running on Kubernetes, and it works. So I'm building a lot more certainty. So now let's do something else. Let's say that I add something else and say, hey, something else. And I want to delete it. And I click the delete button, and it's not working. It's not working because it's not implemented yet. So that's kind of our task at hand, is we're going to implement the delete option of this to-do list, just to show you kind of how this flow works. So at this point, back to the code, and let's open our server.go. And you'll see it's a fairly simple go up. It has all these index handlers, one to get things, one to post, one to put, one to delete, and then the main function where it gets a connection string and starts the service. So fairly standard. So in this case, if you notice here, we don't have a delete handler. It's commented out. So I'm going to just remove this. I'm going to save my file. Normally, at this stage, you would have to do something like, hey, run my service locally, or build a container and push it to a branch and let my CI kind of run or whatever. With Octera, we're going to do something different. And this is here, yes, of course. Thank you. I'm going to save my file. I'm going to go back here. I'm going to stop the server. I'm going to run it again. By now, Octera already synchronized my files. Go build this binary directly on the container on Kubernetes. So if I go here and refresh, now it works. So this is part of the modern dev experience we're kind of like helping our users in our community. The idea is that go fast. Like at this point, I'm going at, as I think things. Hey, you know what? Let's not call it to-do list. Let's call it something else. So I'm going to open the views here. And then let's call it scale 20x to-do list. Save it. Same as before. I start again. I go here. I refresh. And it changes. It's immediate. And this is a fairly simple, I like to do this kind of like trivial changes just to kind of show you the idea behind it. But think about this in the context of a modern application where you have, again, 10, 15 microservices, which nowadays is fairly common, right? You have like 3 or 4 different stores. You have your queue, your cache, your blob store, your node, your MongoDB, Postgres, whatever you're using. You have 5 or 6 microservices, your ingress, Istio if you're doing a service mesh, and a few more things. So you have this fairly complex application. And you have to change something in the middle of it. How do you know that all this like service after service call works? Well, normally it's kind of hard to test, but if you have the ability to spin up the entire application on Kubernetes, on a namespace, where it's isolated per developer, you have access to all these endpoints. It makes your life a lot easier. Like if you notice here, like the demo, the core demo is, hey, Octero up. That's not a Kubernetes command. Everything is encapsulated. The way I create a database, kubectl apply db.yaml. That is also encapsulated. I'm not speaking AWS. I'm not speaking Kubernetes. I'm just having these automated commands. You can do like a makefile if you want, or something like that. And that is what kind of starts to get you to this modern, fast, in our opinion, dev experience. Like some of the members of our community are launching dev environments with like hundreds of components. I've seen applications with like 100, 120 microservices per developer. Because the other thing that's great about this is that because now you have Kubernetes and you're running all your dev workloads there, one thing that Kubernetes is really good at is running a lot of containers at scale. So then you don't have those problems of like, oh, I have to run Minikube and Slack and VS Code and IntelliJ on my laptop, and I'm running out of like memory. All those things are offloaded, but as you saw, you keep your IDE and all the things locally. Go ahead.
Thanks, Josh. So with that application in general, it's like you have like the hot reload thing and the debugger, and like if we're talking developer experience, that's usually what's a pain in the ass, right? Like being able to change the code and the hot reloads, my React thing, Angular, whatever that you have over here, and in that scenario, it seems like you would have to. You don't have that, or maybe I'm misunderstanding, right? Like
It's done in this particular demo, but all of those things is part of what we enable. You're completely right. Like a more modern, a more complex demo that we have, remote debugging, automatic reloading. For this demo, I wanted to show you the pieces, so I want to go like step by step. But yes, once you're building this complete dev experience, all those things you said are crucial. You want to be able to give your team the ability, and I don't know if this one is enabled. This one is not, but I'm going to show you one of our kind of more complex examples is this application. You'll see that it includes, and you can check it out on GitHub, it includes a remote debugger. And if we go back to this definition here, it's a more complex definition, has more services, more commands, and you see that we're forwarding the remote debugging ports. In this case, it's using Maven. It has a hot reloader integrated, so you can do that. Like the same thing I show you. In this case, this demo doesn't have it, but there's this Gene is one of my favorite hot reloaders for Go, because you need to set all those things. And that is crucial. As we think of next in dev experiences, tools like Octero, like Crossplane, like Telepresence, like Loft, like others, are coming up with this kind of building block so you can build this kind of developer experience where every step that your developers are normally doing by hand, if you can codify it on a file as developer experience as code, you make it so much easier because then it's less things to worry about. Like for me, moving dev workloads to the cluster, use the same configuration as you have for production or as close as possible, step one. Step two is build all this automation. So the entire dev experience is fully automated, where all I have to do is open VS Code, click the debug button, and have it attached. Or I open a remote terminal, and if I prefer to like build and restart, you can do it. But it's something that if you as a team come together, build this file, it makes things a lot easier, because then you don't have every developer reinventing the experience and creating all these different ways of doing the same thing, which in my opinion are not very practical. You waste time doing those things rather than investing that time on building cool things, whatever your project, whatever your product your team is building. And that is the key with this. So Octero supports all of those things. We have samples. If you go to Octero, GitHub/Octero/samples, we have more examples on like any framework with debugging, hot reloading for like compile languages, for anything from like C, Rust, Java, Python, Go, and more. But a great question, thank you. Any other questions at this phase of the demo? Please go ahead. Let's make this as interactive as possible.
Yeah, my question is actually about Crossplane. We tried out Crossplane sort of 18 months ago, and immediately it caused slowdowns on our Kubernetes clusters because there's just so many CRD resources that get created. Do you know if that problem has been resolved?
It is. The CRD problem, it's actually, they have a really interesting blog post on all the stuff they had to contribute back to upstream Kubernetes to fix that issue. Yeah, it's solved now. Yeah, but if you're looking at a more modern version of Crossplane, I think 1.11 is the latest. That issue with the CRDs and kind of like the long, fast polling, it's gone. Now it's a lot easier.
And do you know as well if there's a minimum Kubernetes version that's required to get those fixes?
There is, but I don't remember. For this demo, my cluster was in 121, and it didn't work. But then I went to 123, and it works fine. So I know that at least 123 works, which is already like a couple of years old. So I think being in a modern, overall, being in a modern version of Kubernetes, I know sometimes it's hard. It does solve a lot of problems. Like we have the same issue in our company where we want to support the latest versions because there's so much, everything is improving so fast. Every version of everything, of Crossplane, of Kubernetes, of Octero, brings so much goodies that it is kind of convenient to stick around. But yeah, it works really well, and the performance issues are fairly solved. And if you're running into any of this, please join the Crossplane community, because they're always looking for more feedback on this and try to figure out what should the community prioritize. And I like how Crossplane has this very clear division between the commercial outbound and Crossplane. And it's very clear, and whichever side of that are you're going to get the support you need, whether it's from the community or from the company. I highly recommend joining that Slack channel. It's super useful. I'm there all the time, so you can find me there too.
Thanks.
I will add that there was a lot of work in core Kubernetes in 1.2.5 and 1.2.6 to just refactor a bunch of small things to make CRDs perform better overall. So yes, I realize that means upgrading to the current version, but... Okay, more questions?
I was late, so I missed a big chunk of this. So I don't know if you addressed that in the beginning, but there's obviously Scaffold and Garden and Tilt and that kind of stuff, and Octero plays in the same space and that kind of stuff. What's the sort of distinguishing feature of we played around with it. I played around with it. I liked it. It was easy to get started and that kind of stuff. Scaffold seemed to have more capabilities and those kind of things. But do you target sort of different niches or that kind of stuff? Or if you can talk about that, it'd be great.
Yeah, and of course. And that's one of my favorite things about the space is there's so many different choices, both open source and commercial. And it's important to understand the differences so you can pick whichever fits your workflow better. High level, Scaffold is very focused on automating all these phases. It's build, opportunistically build, push. One thing they're very focused on is that. It's I have code, build it, push it, redeploy my application in Kubernetes, wherever it is. That's kind of their main thing. Telepresence is more focused on kind of playing with the networking rules so that you can redirect traffic from the cluster into your local machine, and then in this example with telepresence, you'll be running the service locally, and then Kubernetes will be sending the requests into my machine and then back, and Telepresence kind of does all the proxy redirecting magic. Octero is more focused on moving your workloads to the cluster and having this experience where it feels like it's your local machine, but everything is running remotely. Like for us, one of the key things we want to like remove from the typical inner loop is having to build the container. Building a container and pushing the container and redeploying your application, no matter how fast and optimized that is, still takes a few seconds. And it's very annoying. This model where like, my code's here, and then I have this remote terminal where everything is there, and then I just make a change and run my process. We believe it's a lot faster. We believe that kind of gives you the same feeling as when you're writing code locally and you're testing fast, but now you're seeing the changes applied in Kubernetes. So there's some nuance here, and I think you have to use them to kind of figure it out. For us, not having to redeploy, not having to build, not having to think about those things, and think in terms of like, I change my code and I see the results as fast as possible on Kubernetes in a realistic way that you feel, hey, my code works. That is one of the guiding lights for our project compared to others.
But if I don't have to wait for my containers to build, when will I take my coffee breaks?
What was that again?
I said if I don't have to wait for my containers to build, when can I take my coffee breaks?
When you're done, because you're going to be done so much faster. That is true. That is true. I don't run around the halls anymore.
One thing I know that like developers sort of asked recently, at least in my company, is like REPL access and that kind of stuff, right? Like, so it's nice, right? Like you got the thing restarted, you can refresh, you got some changes, and you can like test it that way. But a lot of them like want the REPL access and do like the breakpoints and that kind of stuff. Like, how would you do that with Octero?
Yeah, so that works. Octero integrates, and I should put that in this demo. Octero integrates with like the remote debugging standards that VS Code and IntelliJ have been pushing. So you set it up, and kind of like, just really quickly, I don't have this one running right now, but in the case of this one, for instance, with Go, we forward this port, 2345, which is Delph's default port. And then what you do is you start the debugger, automatically Octero will start the debugger server on your container, and then it will forward the port, and then VS Code just connects to that port, and it will give you this ability to like, which is to me is super useful, is the ability to like attach a debugger to a container, like from your local IDE to a container that's running on Kubernetes. And then you make some changes, you deattach, you restart the process. That cycle is available. That's one of the key things of this new experience, is going away from println for everything to like actually sticking a debugger. Hot reloading is something else that, depending on that's not something we do natively. We depend on the language's capabilities around this. But most major languages now have like whether it's native or through like libraries, they have hot reloaders, and it's something else. Like Node does it natively, Python has one, Spring has one, Go has like the Gin and a few others. So putting all these things together is part of what Octero enables you, and that's when you put them on the file. Like here, you can see that for Maven, we have like Maven Spring Boot. For this one is Yarn Start, which is running NodeMon to kind of like hot reload for Node. That's part of what experience that you can build through Octero, plus all these other projects or building blocks of your languages.
Pods that they're running, right? Because it's not just forwarding the port.
Yep.
If you have like, 6 pods or whatever, and like it's going to this one, you're debugging this one. So it's like for development, you switch the amount of containers that you may have. You may only want one to debug it, right? So how does this handle?
Yeah, so what we did with Octero right now is we downsize to one. Like when you're developing, if you have like 4, let's say you have a deployment with 4 pods, we will downsize to 1. We're doing some research to see how can we support multiple pods, because it's something that has come up again multiple times in the community. But so far, this model of like for development, just 1 pod, it has been fairly convenient, because also when you're thinking of like synchronizing code and kind of restarting processes, you don't want to do it 4 times. Like one thing Octero supports is this model where you have a main service and kind of like children service where you sync. Imagine like the Django model where you have like the main thing and then the queues. You can do that with Octero and kind of like chain restarts and hot reloads, but you can't do multiple pods of the same deployment just yet. But that, for me, actually, it's kind of it's a feature. We designed it that way for that scenario, to make it easier to do debugging, to understand when something is not running, to check out the logs. There's another command that I didn't show called Octeto logs that will dump the logs of your pod. It's just a wrapper on kubectl logs pod name, but it's just one more thing where we want to make it simpler for developers. Rather than having to figure out, hey, kubectl, giving your labels and the name of the pod, and then the logs, you just do, in this case, let's see if it works. I don't know if I have it set up here, but Octeto log. And you see, it will start like showing me the logs. In this case, it's not going to show them because I'm actually running disconnected, but it will show you those logs. And that's part of this effort of like giving developers these abstractions and this automation to build that experience. If you want your developers to have remote debugging capabilities, you can set it up. If you want them to run something locally, the rest remotely, is that as well. And as I was saying earlier, what I'm really excited, I've been working on developer experience for many years. It's really cool to see all these emerging, competing, quote-unquote, projects, because it's great to have all these different points of view on what developer experience should look like. And we decided to be fairly opinionated in some things, and others we care less. And then there's other projects, like I highly recommend you check out Scaffold, Telepresence, Garden, Octeto, DevSpace. There's a few more out there. Especially, but what's key here is, as you think of your next-gen cloud-native experience, is to think of how you can bring all these other tools, like Crossplane, like Kubernetes, like namespaces, into the hands of the developers. Because this whole world of like decoupling the developer local inner loop experience from what production looks like, it creates a lot of pain. You have all these bugs that only happen in production. You have developers who have zero visibility. I've met people who are like, developers just write code locally on Python, no containers, no Kubernetes, and that's only a production constraint. And I'm sure they have their reasons, but that causes delays, slowdown. Developers then don't know how to debug things. So giving developers access in a controlled way with a default experience makes them a lot more productive, makes them, you have to give that balance, right? You want them to be more productive. You do need to make sure like the cognitive load is not like huge, but that's where tools like Octeto are trying to like make it a lot easier. And as you saw, Octeto build, Octeto deploy, Octeto logs, Octeto up. And that's all you need to do, and then behind the scenes, all this orchestration of creating resources, managing namespaces, pods, injecting things is happening. We have a lot more in the CLI, so if you're interested, check out our GitHub repo. We have a lot of examples and more complex ones, multiple services, different stacks and all that stuff. And if there's anything you see there that we don't support, we have a channel on the Kubernetes Slack, and we also have this is fairly new, a community site, community.octeto.com, where you can join and ask questions, and we have a lot of people from the community participating. Part of what I want to do and why I wanted to come to Scale is to kind of like start engaging more with the community and hopefully get more people to participate. We're always looking for people who want to help with like pull requests, issues, use the project, give us feedback, and participate. So I finally want to like leave everybody with this thought is like, hey, if your application is meant to run in Kubernetes, why don't you develop it on Kubernetes? And that is kind of one of the mottos with our projects, something that I always like to leave kind of at the end to kind of people think about it. And you have to make your own opinions. But if you agree with us, well, hopefully our project can help you kind of get there faster. And as always, please start our repo, like it, subscribe. GitHub.com/octeto, GitHub.com/crossplane. Crossplane, they're both fairly easy to remember. They both have big communities, and we're always looking for contributors, speakers. If you ever want to talk on this with me, I'm always looking forward to chatting with more members of the community. Thank you very much. I hope this was useful. Thank you for the invitation to speak in Scale. Thank you for asking the questions as it goes. I love when that happens, but are there any final questions before we all get ready to Ken's closing keynote?
Sometimes in local development setups, we end up using something like Terraform to configure a third-party service like GitLab as an example, or GitHub or something like that. With Octeto, is there hooks or integrations that you can use to do that sort of thing?
Yeah, there are. So the kind of the first level integration that we have, I'm gonna open back Octeto YAML, is here. Like this is a step called deploy. You can run anything there really. Like here I'm using kubectl, but let me just show you this example. Here, we're running Helm. And then I have a sample the other day. Let me see if I can find it real quick. This one. I have this other example. It's with Lambdas. And here you can see that we're actually using SAM, which is like the CLI for serverless from AWS. So you can run whatever you want. And the new version of Octeto now has this option where you can pass an image to that specific deploy step. And we introduced this new model called Octeto deploy remote. What this does is it will execute all this command list directly on the cluster, which means that even if you don't have the Terraform CLI locally or kubectl locally, if this image that you provide has that, then you can run it, which is another step towards centralizing the tooling you're using, the configuration, so you don't have to like set up, a Terraform CLI on every machine. So yeah, you can integrate this way. We're looking for ideas on how to better integrate. We kind of chose to go with this kind of like very open, bring your own scripts at the beginning to kind of help us understand where this goes. But we are trying to invest a lot in this idea. We're calling this concept kind of external resources, which is the idea of like how do you mix Octeto dev environments on Kubernetes with things like Terraform, Pulumi that are running in other places, right? Like Crossplane is an easy integration because they both speak Kubernetes, but it's not the only tool people use to provision infrastructure. And we want to be open and integrate with any other open standard out there. So if you have any ideas, any comments or things that don't work, please go to our community. We have a section on feature requests. I'm there. Always you'll see me and some of the other members of the team there. Or directly open an issue on our repo as well. But yeah, that's kind of the way. The idea is, part of what we want to do here is we don't want to force people to rewrite their applications to work with Octeto. We want them to be able to reuse. Like that's why like Helm, like, hey, use your own charts. kubectl, use your manifest. If you're using Kustomize, use that. If you want to use Terraform, call your Terraform scripts and then just kind of like feed that information into Octeto so we can use it for the dev environment. That's kind of the goal. I hope we're making it, but if you try it and you see things that are kind of like iffy, please, we're always looking for feedback. I'm a developer, and we're building this for developers, and the more developers we get involved, the better the experience will be.
Thanks. I really enjoyed the presentation. So if I see like the benefits like with hot reloading and working in a cluster and something like that. If I wanted to like convince like my team to use Octeto, for example, what are kind of some talking points, or what are kind of common like things that people say, like, oh, I'd rather work this way. What's the best way to kind of go about thinking
Great
about
question.
it?
One of the first things that we hear when teams adopt Octeto is when you kind of hit that point where like, hey, I can't run this locally anymore. It has too many components. It's kind of very confusing. Like, some of our kind of like first kind of like major kind of users, where companies say, hey, I'm running this 5-6 things, but it's a big Java app. I have like Cassandra, Elasticsearch, and a couple more things. So that's a good driver. One good way to start is by using Octeto to deploy all your data stores in Kubernetes, and then kind of keep everything local. That's a good way to kind of show, hey, sure, keep your code locally, but everything else, start moving it away. And then through that, we've been seeing that very helpful. The other thing which is nice is the fact that you can just put this in the repo, right? So it's like, hey, it's there. Let me show you how it is. You don't have to use it if you don't want it. Like, it's there. It's the same way that, like, you can have a configuration for VS Code, but if you're using IntelliJ, it's still there. That's another one. Another one that works is we have a plugin for VS Code. If you're using VS Code, let's see if I have it installed here. I don't have it here, but if you go to extensions and search for Octeto, we have a plugin for VS Code. That's very easy. It kind of like automates all these commands I show you, so it's an easy way to kind of get your team started. But the main thing for me is talking to your team about productivity, about, hey, how much time are you spending on things that are not critical for your team? Like, what is your team good at? Is your team good at building, features, or at running around setting things up all the time? That for me it tends to be the most successful conversation. Like, hey, you want to build features, you don't want to spend like days setting up your local machine. Well, automate it, and that's where like Octeto makes it easier. And finally, the other thing is Octeto works with any IDE. So whatever you're using, that's one fight you don't have to fight. If it's VS Code, if it's IntelliJ, if it's Vim, Emacs, Nano, I don't know, like SED, any of those things, it just integrates. So that's also an easy way to kind of like intro people. But happy to brainstorm on this. If you want your team to use it, let me know. I'm always looking for chatting with more people and seeing how we can make this easier and more obvious for more and more people.
Yeah, can you talk a little bit if there's going to be more full VM support? I know you and I talked, but versus just container.
Yeah. So right now we're very focused on microservices and containers, but part of our efforts are to integrate with other things like that, like VMs. One of the things I'm experimenting with actually is with KubeVirt, which is it's a really cool project that allows you to provision VMs through Kubernetes, and you can use the Kubernetes API to manage it. So we're looking into ways to integrate with that as a way to expand this idea of dev environments to containers, to serverless functions. A few years ago, I gave a talk at KubeCon on OpenFaaS and Octeto, because we're fully aware that not everything is containers. And as this idea, I think the idea of like this remote dev environment with one command transcends whether you're in Kubernetes, serverless, or containers. I think everybody needs something like this. We're trying to figure out good ways to plug in with all these other components as well. And the first step for this is this idea of external resources, to start bringing like cloud resources, databases, and then we'll look into things like VMs, serverless, and a myriad of formats out there. All right, thank you very much. I hope it was useful.